Linear programming is a mathematical optimization technique used to maximize, optimize, or minimize unobjective functions like cost or profit. It's related to manufacturing since linear programming helps to define the specific amount of goods that need to be produced and sold to minimize the costs or maximize the profit of a business within demand, timing, availability, and other constraints. The objective function and the constraints make up the feasible region, which is the purple area in the graph, where the optimal solution is going to be found.
AMHA Design is an architectural design studio based in Wiki, Ecuador that sells from beds, sofas, housing accessories, and many more. Two of its branches are in charge of decorating spaces and selling the final products to customers, but the third one, AMHA Lab, is in charge of manufacturing. Today we're going to talk about manufacturing of fabric, as AMHA wants to minimize the cost of this process, which are basically of raw materials and electricity costs, and simultaneously meet its final product demands. Here we can see the process of transforming cotton and polyester into yarn and then into fabric that takes 5 stages that yield 4 products sold as inventory. If some materials are not used to be sold as final products, they are sent to the next stage. The units used throughout this presentation are rolls of yarn or textile of 1 kilogram each. The stage 1 is called the spinning, is where AMHA takes the raw materials to process them into yarn, uses a spinning machine, which consumes 0.35 kilowatts per unit. The raw materials used up per unit are valued in $2.2, and it takes around 1 minute to produce 1 unit of yarn. As I told, sometimes part of the yarn produced is sold directly to customers, which can be businesses or individuals, instead of continuing the process of turning into the final product of the process, which is fabric. The yarn not sold is passed to stage 2 to continue with this process. According to María Hanze, who is AMHA CEO, the demand of yarn is at least of 40 units per month. The second stage is sizing, which consumes 0.12 kilowatts per unit, and it takes 1.5 minutes to produce 1 unit. Around 10% of this sized yarn is sold as inventory with a demand of at least 80 units per month, and the rest is sent to stage 3, which is weaving. That consumes 2.4 kilowatts per unit, and it takes 1 minute to weave yarn into red textile. Around 80% of plain textile is sold to customers with a demand of at least 300 units per month. The fourth stage is subliming. It consumes 15.75 kilowatts per unit, and it takes 20 minutes to put the color or design to each unit of fabric. There's a demand of at least 150 units of printed textile per month, but in this process there's an excess of 4% of gray fabric because the printer does not reach all of the textile, and ink use per unit is valued at 30 cents. The A6 textile is freighted in stage 5 to be sent back to stage 3, process that consumes 0.015 kilowatts per unit, and it takes 2 minutes to fray 1 unit of fabric. So the cost of production of each stage, knowing that 1 kilowatt of electricity in Ecuador costs around 4 cents, are the ones displayed at this table, along with the raw materials cost. As AMHA wants to minimize the cost of production, the objective function will therefore be the cost of each unit multiplied by the number of units produced in each stage, which are the variables of the problem. It is important to know that this is not the same as the number of final products produced in each stage, which correspond to a portion of the units produced in that stage.
Time constraints. We know that there is 120 hours in a month, so we're basically changing from units produced in a minute to units produced in a second, and have a proportion of an hour that it takes to produce 1 unit. And for the objective function, we have to know that all of the hours combined for each variable has to be less than 120.
The demand constraints are related to the final products. For example, with the first one, we know that the demand for yarn was of 40 units, so the amount that goes from stage 1 to stage 2 is not the one of the final product, but the difference between is the one of the final product, so it must be greater or equal than 40. And the same with product 2. We know that 10% of stage 2 must go towards the final product of sized yarn, so 10% of x2 must be greater or equal than 80. And what happens with the fourth product is that as 4% of it goes to waste, only 90% of x2 must be greater or equal to 150, which was the demand for color and design fabric. The production amount constraints are related to the demand constraints, because if 10% of x2 goes to the final product, 90% of x2 must therefore go to stage 3. So 90% of x2 minus the amount produced in x3 must be equal to 0. And the same with the other 2 stages that have final products with percentages.
All the variables have to be greater than or equal to 0. We saw this problem using Excel solver. On the screen right now is the problem information. Now it's the objective function and constraints. And for the inputs of solver, we put all the constraints. We put all of the integer constraints as the roles of yarns or fabrics are integer quantities. Our objective is to minimize, and the method is simplex LP. Here are the results, and here are the results with meaning. The minimum cost AMHA could incur from this manufacturing process would be $3,180 per month by running the machines 145 hours per month. These are the quantities of units to be produced in each stage, along with the final products to achieve minimum costs. AMHA must meet all of its product demands, but to produce and sell everything, AMHA must sell 45 more units of product 2, 600 more units of product 3, and 66 more units of product 4. Demand can be enhanced with different sale promotions such as bulk offers or discounts. Viewing as how producing only 9 units of frayed fabric per month is an extremely small amount, AMHA could decide to ultimately remove stage 5 completely. The following scenario is going to be solved the same way as the original scenario, but all of the constraints and variables related to stage 5 will be eliminated. Problem information, objective function, and constraints. Methodology is the same as previously used, and those are the results.
As you can be seen, eliminating stage 5 saves AMHA $866 per month, and the hours to run the machines are not 105. Also, the difference between the amount of units produced and the demand for final products are not as large as in the previous case, so less effort will be needed to enhance sales. However, it depends on AMHA's corporate social responsibility and its willingness to become a zero-waste company by continuing to recycling yarn in stage 5.